Hello, classmates. Today we're exploring the river systems in simple terms, like chatting over lunch. So we'll start from the source and flow to the mouth using pictures. Let's dive in. So we have a river system. What is a river system? So a river system is a network of streams and rivers that drain water from land to sea or lakes. So it also includes a main river with tributaries that collect water. As you can see in the diagram, we have the main river that's in between, which is thick, and then we have the smaller ones, which are tributaries that feed the main river. So what is the importance of this river system? So it shapes landscapes, as you can see here in the diagram, but it's not quite visible. We have V-shaped landscapes and also U-shaped landscapes, which are flat. And then what is the importance of it? It shapes landscapes and provide water for life. So let's put it in simple terms. Imagine a big tree but for water. So the thick line, as you can see in the diagram, is the main river, which is fed by the smaller ones, which are called tributaries. So this setup drains huge areas. So let's think of how the Val River system, Val River system water um, waters our farms. So let's proceed to the next slide. So we have the first feature of the river system, which is called the source. What is the source? So this is the highest point. It can be mountains, hills, where water starts. As you can see in the photo, um, this is the Drakensberg mountain. Look at the highest point of the mountain. That's where the water starts. It created some sort of a waterfall. So these are often springs or melting glaciers. It can be a glacier, it can be a melting streams, sort of springs. So water flows down the hill due to gravity. As you can see in the diagram, look at the arrow. So the arrow it shows how the gravity pulls the water down the hill. So let's put it in simple way. So every chain starts somewhere, né? So the source is the high spot, like a mountain tip where water comes from. As you can see in the diagram, gravity pulls it down, just like sliding down a hill. As you can see, my arrow shows how the gravity pulls down the water. Look at this Drakensberg photo. That's our local example, starting the Orange River, which is the biggest river or largest river in South Africa. So let's proceed to the next slide, or to the next feature. So we have what we call tributaries. They help us. You can call these ones the branches. So let's define the tributaries. So these are smaller streams or rivers joining the main river. As you can see in the photo, we have the main river in between, and then the smaller ones. They feed the main river. So they are joining to the main river. That's what we call a tributary. So what is the advantage of it? So the importance, actually. So they add water volume, like they also add water volume to the main river, um, like side roads merging to a highway. Yeah, similar to a crossing. Yes. So our example um, is the Val River that joins to the Orange River. So which means the Val River is the tributary of what of the largest river in South Africa. So tributaries are like little helpers boosting the main river's flow. So these ones, they join from the side, as you can see in the picture. They join from the side, bringing extra water like into the main river. So let's put it in an example similar to friends forming up for a project. So in South Africa, The Val River is a tributary, makes Orange River stronger for irrigation downstream. So which means the Val River, it adds water volume to the Orange River, which enhances what? Irrigation. So let's proceed to our next feature. So now we have what we call a confluence, which is our next feature. A confluence, the meeting point. So how can you define the confluence? So this is the point where two rivers, the main river, as you can see in the photo, the main river is the thick one or the bigger one, and the tributary meet and merge. Yeah. So on this confluence, the water mixes and can change speed or sediment load. So as you can see my arrow here, it shows what we are talking about, the confluence. Here, as you can see, the small tributary meets with what? With the main river. So the point where it meets, it's called what? The confluence. So as it meets here, so it mixes the water and can change the speed or the sediment load. Let's put it in simple terms. So now picture two rivers joining together as in the photo. That's the confluence. Look at my arrow, that's the confluence. So water blend here, speeding up or slowing up based on the sizes. So you see the arrow, so the arrow shows what? The confluence. So this is where systems grow stronger. Sorry. So now we have the watershed. What is the watershed? So the watershed can, in simple terms, is called what? The boundary line. The boundary line, it can be a line that divides two things or more. So this is an imaginary line dividing water flow between river systems. So rain on one side goes to the one river, other side to another. As you can see the diagram here, there are little small dots here. So this one is the watershed. As you can see, rain it enhances the flow of water into the right and into the left. So let's put it in simple terms. So watersheds are nature borders. As you can see, the high ridge here, the mountain, are nature borders, keeping waters apart. So it keeps this water and this water apart. Let's think of the Drakensberg. The Drakensberg mountain, it's dividing our rivers. It divides our rivers in South Africa. So what is the importance of this watershed? So the watershed, it helps to predict what? To predict floods. I hope it makes sense. Let's continue to our next slide. So this is our next feature, which is called what? The interflow, the land in between. So let's define the interflow. This is the one of the important features. You'll understand as we proceed why I'm saying it's the important feature of the river system. So the interflow is a land area between two rivers or tributaries. As you can see here, we have two tributaries, or three rather. So the land in between is called what? The interflow. So it's often flat or fertile. As you can see, this land here, it's flat and fertile. Why am I saying it's fertile? It's because you can see there's a lot of cultivation aside. So interflow, it may be maybe a flat land or some sort of valleys. You understand? So let me put it in another way so that you can understand better. So between rivers lies the interflow, this land or area that we are talking about. So it is good for cultivation. As you can see in the photo, this land is cultivated, which means it's fertile Farmers love it because of the fertile soil, obvious, and water, access to water. So, for example, the Free State, some sort of an interflow between the valve branches. Okay, so let's proceed to our next feature. Then we have the last one, which is called the river mouth. So this is the end of the journey of the chain of the river system. So what is this river mouth? So it's where a river meets a sea, a lake, or another water body. As you can see here we have the sea, and here we have the river. So this point where the river meets the sea, it's called what? It's called a mouth, a river mouth. So this river mouth, it forms deltas. What are deltas? So deltas are sediment deposits. As you can see here, there's a lot of sands or deposits here. So this river mouth causes this kind of deposits here, which is called deltas. So water in this area flows slowly and drops low, which are sediments. It can be a sediment, it can be such as sleet and so on. So it's important for ports and or ecosystems. So ports such as what, the Devon port, it also has a river mouth. Yeah. So finally the river mouth, so where it says the goodbye to land, it drains into the ocean, as you can see in the photo here. So building sandy deltas, as I've explained before. So slow water drop slits, as you can see this sand here, it's called what? Slit, creating rich wetlands. So when they say rich wetlands, they means that this soil around this area, it's what? It's fertile. It's also perfect for what? For fishing. So let's go to our next slide. Let's put it all together. This is a real example of South Africa. So let's connect it. So from high sources, tributaries joins what? Confluences. Bounded by what? Or surrounded by what? By watersheds, as you can remember. So over what? Over interflow. Remember, don't confuse the two. A watershed, it's higher, or it's found in high altitude than what? Than an interflow. Don't don't confuse the two. So a watershed, it's a high-lying area which divides two what? River systems or drainage basins. And then an interflow, it's a land which it's a land, or it can be a ridge or hill that divides what? Two tributaries. So don't confuse the two. So let's conclude. Surrounded by watersheds over interflows into the mouth, which is the last key or the last feature of the river system. So let's check out on our map here. So the Orange River start where? In the mountains around Lesotho, as you can check here. So it gets help from the Val River, it drains into Karoo, and ends at what? Alexander Bay here at Northern Cape. So this map shows the full flow of South African river systems. It's easy, right? So okay, let's proceed to our next slide. Why do we study river systems? Why do we study river systems? So river systems helps us to manage floods or droughts, and sustain agriculture, and also protect ecosystems. Understand? So river systems are not just lines on a map, so they feed us, they enhances the production of what, of electricity, and also what, fight what, floods. So quiz time. What is a confluence? Pause for a thought. A name in South African river mouth that you know. So you can share these answers with a friend. Thanks. I hope this clears things up. Thank you for watching.